So in this video, we are going to talk about the Chapter 9 test. Remember, there are some things you have to have memorized. The Pythagorean identities, sine squared plus cosine squared is equal to 1. Tangent squared plus 1 equals secant squared. And 1 plus cotangent squared is cosecant squared. Remember, the reciprocals of the sine is a cosecant, cosine is a secant, tangent is a cotangent. So you just have to put that one over, and then you got it. And then your quotient identities, sine over cosine is a tangent, and cosine over sine is a cotangent. So those are just facts you need to know, just a little reminder for you. So make sure that you have all those facts in your brain. You're going to need them as you go through the process. Now, it's also a good idea to have your unit circle memorized. So remember, your quadrantals count by 90s. So 0, pi over 2 pi, 3 pi over 2, and 2 pi, or 0. Everything in the first quadrant is positive, positive. The second quadrant is negative, positive. Third quadrant is negative, negative. Fourth quadrant is positive, negative. Remember that the cosine is your x, the sine is your y, and tangent is y over x. And that only works for the unit circle. Otherwise, you're going to build a triangle and do SOHCAHTOA. So some ones to remember. Remember, pi over 6 or 30 is square root of 3 over 2 1/2. 45 pi over 4 is square root of 2 over 2 square root of 2 over 2. And finally, pi over 360 degrees is 1/2 square root of 3 over 2. I'm not going to draw the whole thing. Hopefully you know your unit circle. Please look it over. Okay. So this page was the first page on the original review. Okay. So now if you go into Google Classroom, find the material that says like revised Chapter 9 review. It looks like this. If you could please open that now. Now, when we do this, the first one uses our reciprocal identity, that the reciprocal of the cosine is the secant. So if secant is 3 over 1, then the cosine is 1 over 3. So that's all they're doing there. Okay. Now let's take a look at problem number 2. Problem number 2. The first thing you want to do is you want to draw an XY grid and mark the interval that they're talking about. So that's from pi to 3 pi over 2, or 180 and 270. Okay. Pick any point in that quadrant, connect to the origin, connect to the x-axis, put in your theta, and then mark what we know about the third quadrant. Our x is negative, our y is positive, our x is negative, our y is negative, and our hypotenuse is always positive. Now, cotangent, when we build a triangle, is opposite, the flip of opposite over hypotenuse. So, or opposite over adjacent, I'm sorry. It's going to be adjacent over opposite. So this will be our adjacent, which is our x. This will be our y. So put those in. So then next you want to do Pythagorean theorem. So negative 4 squared plus negative 3 squared in parentheses would equal our radius squared. Or 16 plus 9 is our radius squared. So our radius is squared is 25 So our radius is the square root of 25, or 5. Now, if you recognize that's a 3, 4, 5 triangle, that is also a Pythagorean triple, so you can do it like that as well. Now, the sine of theta, you just use SOHCAHTOA to answer the first 3 questions. So sine is opposite over hypotenuse. Sine, cosine should always be proper fractions. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Please make sure that you reduce down when possible. Our final answer would be positive 3/4. Okay. Now, the sine of 2 theta, up on the board, you can find the formula. The sine of 2 theta is 2 sine of theta cosine of theta. So you're just multiplying those values. Earlier, I told you that the sine of theta was negative 3/5, and the cosine of theta was negative 4/5. And so if we put this one over 1, if you multiply all the tops, you get 6 times 4, or 24, and the bottoms would be 5 times 5, or 25. So that's going to be 24 over 25. And then cosine of 2 theta is up on the board. It has 3 different formulas that should all give you the same thing. The cosine of 2 theta is cosine squared minus sine squared. Remember, our Pythagorean has a plus between them. A cosine of 2 theta has a minus between them. And so the cosine squared, just put your cosine value of negative 4/5 in parentheses squared, minus my sine value in parentheses squared. To square a fraction, square the top and also the bottom. Square the top and also the bottom. 16 minus 9 is 7. That is 7 over 25. And then finally, the tangent of 2 theta. Since I am going to require that you do the sine and cosine anyway, just take the sine value that we got divided by the cosine value that we got. And so it would be 24 over 25 over 7 over 25. Now what's great about that is because of the location of the 25s, if you did big C over little c, it does cancel out and it gives us 24 over 7. So that is your final answer for the problem number 2. So build a triangle, label your sides. First, you want to find the 3 original that's missing using SOHCAHTOA. Then you want to use the formulas on the board. Now let's take a look at number 3. For problem number 3, it's a verification. I'm going to choose this side as my answer, so sine to the 4th power. And I'm going to manipulate the other side. Every time I try to say manipulate, I always do weird things. But anyway, 1 minus cosine squared is a perfect substitution as a sine squared, which is great because that's what we're looking for. Now 1 plus the cotangent squared is actually the same as a cosecant squared. Now remember, the thing we're looking for is sine to the 4th. So the flip of a cosecant is a sine. So if we pull these apart, put a multiplication dot between them, you can tell that we know this is sine squared. So it becomes sine squared times sine squared, which is indeed the sine to the 4th power that we were looking for. And so that is how you do that verification. I'm not putting any verifications on it that are not similar to that. So the one on the test will look very much like what you see right there. Okay, there's only one of those. The test looks very much like what you see here. Number 4. These are trig equations that are different than verifications. Equations you can manipulate and solve like an equation. For this one, let's let u equal the sine of x. So it would be 2u plus 2 equals 0, and solve that for u. Now it's an equation. Don't overthink it. Take the 2 to the other side, divide by 2. So you get that u is equal to -1. Now, once you've solved for u, put your trig function back on, and then ask, where does that happen on one loop around the unit circle? So if we think about the unit circle, the sign is our y value. It's -1 down pointing at 270. I want to answer in radians as 3 pi over 2. So that one only had one answer. Now b is a factorable quantity. Factoring is always helpful when you have different powers. You can think of this as 2u squared plus 3u plus 1 if we think of our u as the cosine of x. And that is factorable. You just got to remember your rules of factorization. So that's a quadratic. That factors like that. Just set a 2u here and a u here and a plus 1 and a plus 1. And you can check. You can do the FOILs, inners, outers, and all that other good stuff. And you get that 2u plus 1 equals 0, or u plus 1 equals 0. And you get to solve those independently. So you're just going to solve them. So we get here that 2u equals -1, or u equals -1/2, and u equals -1. Now you're going to put your trig functions back in, so we're asking where on the unit circle is the cosine -1/2, and where on the unit circle is the cosine -1. So the x equals -1/2, or the cosine of x, I'm sorry, is -1/2. Where's the x value on the unit circle? -1/2. Now the cosine is negative in two quadrants, the second and the third. So let's find where the cosine is 1/2 in the second and the third. That would be the 60s over there, 120 and 240. But how do we write those in radians? That would be 2 pi over 3, or 4 pi over 3. And then this one here, the cosine is -1 in one location only, at pi. So those actually have 3 answers. So those are the types I'm going to put, the types of equations I'm going to put on there. Nothing super crazy, but that's the kinds of equations you're going to see from me, okay? And then the last things you need to know are how to use the sum or difference formulas. So that's the last thing that's going to be on the test. Remember, to use the sum or difference formulas, you need either two things that are on the unit circle that either add up or subtract to the value you see there. Now, it could be any two things. It's whatever occurs to your brain at the time. The sign of 15, I'm going to use 45 minus 30, because 45 minus 30 is 15. So in the formula, this will be my alpha and this will be my beta. The formula for the sign of alpha minus beta is up on the board for you to use. The minus ones use the blue signs. So it would be sine of alpha, cosine of beta, minus cosine of alpha, sine of beta. So let's just plop our information, alpha 45 and beta 30, into that formula. So when we do that, we get the sine of 45 times the cosine of 30 minus the cosine of 45 times the sine of 30. Now those are unit circle values. You need to know what they are. 45 is that square root of 2 over 2, square root of 2 over 2. Let's put that here and here. That's an easy one. I always like when the 45s can be used. 30, the cosine of 30 is that larger value, square root of 3 over 2, where the sine is 1/2. Now what? Well, multiply the tops with the tops and the bottoms with the bottoms, tops with the tops, bottoms with the bottoms. Radicals can multiply inside with other radicals. Non-radicals can't, so be careful. And then just write it over one denominator. These usually have a denominator of 4. We usually will see square root of 6 and square root of 2, sometimes added, sometimes subtracted. You know, it just kind of depends upon which formula you are using. So that is example 5A. Next, let's do our last example, and then make sure you turn this in. The cosine of 165 is not on our unit circle, but we can find some things that add up. If it ends in 5, I subtract 45 and see what happens. 120 plus 45 is 165. Both of those values are unit circle values. Now the formula I'm going to be using is the cosine sum formula, alpha plus beta. And then I'll write it down here, and then I'll move it out of the way. Okay. So the formula is the cosine of alpha times the cosine of beta minus, remember the cosine formula uses a negative when you are adding, and then sine of alpha, sine of beta. Okay, so what do we do next? Well, next, let's plop in our alphas and our betas. So that would be the cosine of 120 times the cosine of 45 minus the sine of 120 times the sine of 45. Now 120 is the 60 that is in our second quadrant. So our cosine will be negative, but our sine will be positive. So the cosine will be negative, but our sine will be positive. And then 45 is great because both the sine and the cosine are the exact same thing. Let me move my formula here out of the way. Okay. And now let's just simplify. If I multiply the tops in my first fraction, I get negative square root of 2 over 4. If I multiply the tops in that distributed, that negative in, I get negative square root of 6 over 4. So it's negative square root of 2 minus square root of 6 all over 4. So study this. Make sure you understand how these formulas work. This is what the test looks like that you will take tomorrow. Thanks.